4 fuel depots in the operational rear of the Russian Western grouping of forces struck within a 96-hour window across a corridor running from roughly 40 kilometers east of Kupiansk to the rail junction complex south of Valuyki. Combined storage capacity at the 4 sites, by the most credible open-source estimates, was somewhere in the range of 40 to 60,000 tons of diesel and aviation fuel, with the actual on-hand inventory at the time of the strikes assessed at roughly 60% of capacity. Within 10 days, Russian armored vehicles operating on the Kupiansk axis began exhibiting the specific behavioral pattern that any experienced observer recognizes as a force operating under fuel constraint. Reduced patrol activity, nature age, limited counter-battery movement. Tank engagements broken off after shorter durations than tactical doctrine would have suggested. Personnel rotations conducted on foot across distances that would normally have been covered by transport. Now, I want to be careful with you here, because the temptation when you see a sequence of strikes followed by a behavioral change in the targeted force is to assume a direct causal relationship and move on. The professional discipline required to analyze this kind of operation is to slow down and ask whether the relationship is actually causal, whether the behavioral change you are observing actually reflects the constraint you think it reflects, and whether the constraint, if it exists, is going to persist long enough to produce operational consequences, or whether it is going to be solved by the targeted force inside a timeline that makes the strikes operationally meaningless. Fuel interdiction is one of the oldest forms of operational warfare. It is also one of the most consistently misunderstood because it produces results on a timeline that almost never matches the news cycle and against a metric that almost never appears in the immediate damage assessments. You strike a depot. The depot burns. The footage is dramatic. The footage shows what looks like a significant loss of stored fuel. And then, depending on the resilience of the targeted logistics system, one of two things happens. Either the system absorbs the loss through redistribution from other depots, draws down operational reserves to maintain forward fuel flow, and continues functioning at near normal tempo while the destroyed depot is rebuilt or replaced. Or the system, which was already operating closer to the margin than the targeting cell may have known, tips into the kind of cascading shortage that produces visible operational effects within days rather than months. The difference between those two outcomes does not depend on the size of the strike. It depends on what the strike interacts with, and the Ukrainian targeting against the Kupiansk axis, based on the behavioral evidence that has been visible since the strikes, interacted with a Russian fuel distribution architecture that was already operating significantly tighter than the public reporting had suggested. Let me set the operational context, because the geography of fuel logistics in this sector is the part of the analysis that determines everything that follows. The Russian Western grouping has been conducting offensive operations on the Kupiansk axis for the better part of 14 months, with the operational tempo varying significantly across that period, but the overall direction of effort sustained. Armored operations at this tempo, conducted by formations that include a substantial proportion of older platforms with high fuel consumption rates, generate fuel demand that has to be met by a continuous distribution network running from the strategic depots in central Russia forward through a sequence of operational and tactical fuel transfer points, ultimately to the unit-level fuel trucks that move the product into the vehicles themselves. Each link in that chain has its own capacity, its own resilience, and its own vulnerability profile. The strategic depots in central Russia are largely beyond the reach of Ukrainian strike systems, and they have not been the focus of effective interdiction at this stage of the war. The operational level depots, of which the 4 targeted in this sequence are representative, sit in the band of terrain that is within range of Ukrainian long-range systems, but that is generally protected by enough distance from the front line to avoid casual attrition. The tactical level fuel transfer points are within standard artillery and short-range strike envelope and are routinely targeted, but they are also small, dispersed, and individually difficult to interdict at a tempo that produces cumulative effect. The operational level depots are the load-bearing nodes. They are the points in the system where strategic level fuel supply gets converted into operational level distribution capacity. Strike them effectively, and the system does not lose access to fuel in the absolute sense. The strategic supply continues. What the system loses is the capacity to convert that strategic supply into the kind of forward distribution flow that sustains armored operations at tempo. The fuel still exists. The mechanism for moving it to where it needs to be no longer exists, or exists at a reduced capacity that cannot meet the demand the operating forces are generating. That is the conversion mechanism the Ukrainian targeting attacked. And the conversion mechanism, once it is degraded below the demand it is supposed to support, produces operational consequences that are not solved by simply having fuel somewhere else in the system. The fuel has to be at the unit. It has to be at the unit on the timeline the unit requires it. And if the conversion infrastructure is no longer capable of producing that timeline, the unit operates under constraint regardless of how much fuel exists at the strategic level. The 4 targets struck in the 96-hour window were not selected at random. The targeting cell, based on the pattern of strikes, had identified specific depots in the operational network, whose loss would force the remaining depots in the sector to handle distribution loads they were not engineered to handle, on routes they were not optimized for, with truck inventories that had been allocated based on the original network configuration, rather than the configuration that would exist after the strikes. The damage was not just to the destroyed depots. The damage was to the system's capacity to compensate for the destruction, and that secondary damage is the part that matters operationally. Now, I want to take you inside what this looks like at the level of one Russian tank battalion on the Kupiansk axis during the second week after the strikes, because the abstract description of a fuel distribution problem only becomes operationally meaningful when you can see the human picture inside it. A tank battalion commander, lieutenant colonel, in a forward command post roughly 12 kilometers behind the line of contact. His battalion has 31 operational T-72B3 main battle tanks at the start of the period, which is already below the table of organization for a full battalion, but is the operational reality of any Russian armored formation that has been in sustained combat for the past year. His normal fuel allocation under the distribution system as it existed before the strikes was sufficient to maintain an operational tempo that included regular patrol activity, full participation in scheduled offensive actions on the brigade level, and the kind of routine vehicle movement that armored formations require to maintain mechanical readiness and avoid presenting static targets to enemy reconnaissance. The fuel trucks have been arriving late. Not catastrophically late, 12 hours, 18 hours, occasionally 24 hours behind the scheduled delivery window. The deliveries, when they arrive, are roughly 70% of the allocated volume, not zero. Not catastrophic, just enough below the required volume to force the battalion commander into a daily series of decisions about which vehicles get fueled, which vehicles get held at reduced fuel levels, and which scheduled activities get scaled back or postponed to preserve fuel for activities he judges more important. He is a professional. His staff is professional. The decisions he is making are individually defensible. He prioritizes fuel for the vehicles that are positioned to respond to immediate tactical contingencies. He holds the vehicles in his reserve at reduced fuel levels, with the understanding that they can be topped off if they are required to move. He scales back the patrol activity that was generating fuel consumption disproportionate to the tactical value it was producing. He reschedules a planned battalion-level movement to a different sector because conducting that movement at the current fuel state would leave the battalion without sufficient reserves to respond to any developing situation in its current sector. Each of those decisions taken individually is the correct decision. The cumulative effect of those decisions, taken across roughly 14 days, is that his battalion is now operating at a significantly reduced operational tempo. His patrol activity is at roughly 60% of the previous baseline. His participation in brigade-level activities has been limited to engagements he judges essential. His vehicle maintenance, which requires fuel for the test movements that confirm mechanical readiness after maintenance actions, has fallen behind the schedule the maintenance protocol requires. And his counter-battery response, which depends on the rapid movement of armored vehicles to alternative firing positions after they have engaged Ukrainian targets, has been slowed by the fuel calculations he has to run before he authorizes the displacement. None of that is visible to higher headquarters in the way that a vehicle loss or a casualty count is visible. The battalion is still there. The vehicles are still operational in the sense that they have not been destroyed and the crews have not been killed. The combat power, by any quantitative metric that the higher staff is using to track the battalion status, is essentially unchanged from what it was 3 weeks earlier. What has changed is the rate at which that combat power can be applied to the operational situation, and that rate is not appearing in any of the reports the battalion is generating, because the battalion commander is making the adjustments at his own level rather than reporting that he is unable to execute his assigned missions. That is the moment. The moment when an experienced commander, working with the discipline and the professional judgment that his training has produced, absorbs a fuel constraint at the battalion level by quietly degrading his own operational tempo, rather than escalating the problem to a higher headquarters that may or may not have the visibility to solve it, and that, in his experience, is more likely to interpret the report as a failure of his command than as a failure of the system supporting him. The system above him is not getting the signal that the constraint is producing operational effects. The system above him is getting the signal that the battalion is continuing to function at acceptable levels because the battalion commander is making sure that the signal continues to read that way. Pull back from the battalion and apply the same dynamic across the dozens of armored battalions operating on the Kupiansk axis, and you can see how the fuel constraint produces the cumulative behavioral change that has been observed at the sector level. No single battalion is reporting failure. Every battalion is making the same kinds of internal adjustments at the same kinds of margins with the same individual rationality. The sector-level effect is the aggregation of those individually invisible adjustments, and the sector-level effect is what shows up in the patrol activity reduction, the counter-battery degradation, the slower personnel rotations, and the shorter engagement durations that any competent intelligence cell watching the sector can observe and correlate to the timing of the depot strikes. Now, I want to talk about what this engagement reveals about the structural relationship between operational logistics and combat capability, because this is the part of the analysis that travels beyond this specific sector and tells us something important about how modern conventional warfare actually works. There is a tendency in popular military commentary and in a fair amount of professional commentary that should know better to treat combat capability as a function of the equipment and the personnel of a unit, with logistics as a supporting function that either does or does not enable that capability to be applied. The framing is convenient because it allows analysts to compare orders of battle, count vehicles and personnel, and produce assessments of relative combat power without having to deal with the much harder question of whether the combat power can actually be applied at the rate and the locations the operational concept requires. The framing is also wrong. Combat capability is not a function of the equipment and the personnel. Combat capability is a function of the equipment, the personnel, and the rate at which logistics can sustain the equipment and the personnel in the operating environment they are positioned in. Strip the logistics from a unit and you have not reduced the unit's combat power by some percentage. You have eliminated the unit's combat power, regardless of how much equipment and how many personnel are still physically present. The equipment without fuel is not equipment, it is sculpture. The personnel without rations and ammunition are not soldiers. They are personnel on a clock, and the clock runs out at a rate that depends on what is in the local supply. This is not a new observation. Anyone who has spent professional time in a sustainment command understands the dynamic at a deep level, and the professional literature on it goes back further than any of us in this conversation. What has changed in the current era of warfare is the precision with which an adversary can attack the logistics architecture at the operational level and the consequent acceleration of the timeline on which logistics interdiction produces visible combat effects. In earlier eras, attacking the operational rear was a difficult and resource-intensive proposition. You needed long-range aircraft, you needed targeting intelligence that was hard to generate, and you needed to expend significant ordnance against targets that might or might not produce the effects you were hoping for. The cost-benefit calculation often favored attacks against the forward edge of the battle area, where targets were more accessible and where the effects were more immediately visible. In the current era, the proliferation of long-range precision strike systems, combined with the maturation of overhead reconnaissance that can identify and track operational-level logistics nodes with high confidence, has shifted that cost-benefit calculation significantly. The operational rear is now within range, the targeting intelligence is now available, and the ordnance required to produce meaningful damage to a fuel depot or an ammunition transfer point is no longer prohibitive in the way it was in earlier conflicts. The result is that the operational rear, which used to be a relatively safe space in which logistics could be organized at a tempo that the forward edge could not threaten, is now contested ground in its own right. The Russian Western grouping was operating on the Kupiansk axis under the implicit assumption that its operational-level logistics architecture was secure enough to support sustained armored operations at the tempo the offensive concept required. That assumption was load-bearing. It was the assumption that allowed the Russian planners to commit armored formations to the offensive operations they were conducting, with the expectation that the formations would be fueled and sustained at the rates the operational concept assumed. When the assumption stopped holding, which is to say when the operational level fuel architecture was demonstrated to be vulnerable to interdiction at a tempo the Russian system could not compensate for, the entire operational concept built on top of that assumption began to compress. The compression has not yet produced a visible collapse. It may not produce a visible collapse in the sense of a sudden offensive failure or a dramatic Russian withdrawal. What it is producing and what the next several months are going to demonstrate is a steady degradation of the offensive tempo that the Russian formations on this axis can sustain. The offensive will not stop. The advance will not reverse, but the rate of advance will slow. The casualty exchange ratio will shift against the Russian side because the formations will be operating at reduced tactical flexibility, and the strategic timeline on which the offensive was supposed to produce decisive results will extend in ways that compound across multiple operational cycles. Ukraine, by attacking the operational fuel architecture rather than the forward formations, has chosen to fight the war the formations are conducting rather than the formations themselves. That is a different kind of operational concept, and it is one that is increasingly available to any force that has invested in the long-range precision strike capabilities required to execute it. The Ukrainian General Staff has been investing in those capabilities deliberately and systematically for the better part of 3 years. The investment is now producing returns of exactly the kind the planning cycle was designed to produce. What this means for the broader question of how the war on this front is going to develop, and I want to be careful here because this is the part of the analysis where the professional discipline matters most, is that the Russian offensive on the Kupiansk axis is now operating under a constraint that was not present when the offensive was conceived, that the Russian system has not yet developed an effective response to, and that the Ukrainian targeting cycle is positioned to maintain through continued interdiction of the depots that the Russian system would need to use to reconstitute the distribution capacity it has lost. The Russian response, when it develops, will likely involve some combination of dispersing the fuel storage across a larger number of smaller sites, hardening the remaining operational depots against precision strike, increasing the air defense coverage of the operational rear, and accepting the additional cost of moving fuel through more, smaller distribution channels rather than fewer, larger ones. Each of those responses is available. None of them is free. And the cumulative effect of implementing them is a substantial increase in the resource cost of sustaining the offensive at exactly the period when the Russian system is also dealing with the broader resource constraints that have been visible across multiple categories of military expenditure for the past year. The strikes against the four depots did not end the war on this axis. They did not even end the offensive on this axis. What they did was raise the cost of conducting the offensive in ways that are not immediately visible, but that compound across the operational timeline, and that the Russian system is structurally less capable of absorbing than the Russian leadership currently understands. The frontline vehicles are running dry. The reason they are running dry is not that the fuel has stopped existing. The reason is that the architecture for delivering it has been demonstrated to be vulnerable in ways the operational concept never accounted for. And when an operational concept depends on an assumption that has been demonstrated to be wrong, the concept does not adjust to the new reality on its own. It continues to operate as if the assumption were still valid until the consequences of the wrong assumption have accumulated to the point where the operational concept can no longer function. The accumulation has begun. The point of dysfunction has not yet been reached, but the trajectory between now and that point is determined by the system that has already been damaged, and that system is not capable of repairing itself faster than the adversary that damaged it is capable of damaging it again.